In this video, we'll study about general characteristics of the compounds of the alkali metals. Now we'll study the compounds of the alkali metals. Before this, we have done the properties of alkali metals. So first compound that we'll take of alkali metals is oxides and hydroxides of alkali metals. And we have done that lithium forms mainly monoxide. Sodium forms mainly peroxide. And other alkali metals, potassium, rubidium and cesium, they mainly form superoxide. And the reason for the stability of superoxides down the group, it increases because big size cations, they stabilize big size anion. This already we have done. So why down the group superoxides they will form? Because the big size cations, they will stabilize the big size anion, that is superoxide. And these oxides, when we add water to these, they will hydrolyze in water and they will form hydroxides. They are forming hydroxides. So if I take lithium monoxide, sodium peroxide and other alkali metals, superoxide like potassium superoxide I'm taking, and when we add water to these, they will form hydroxides. So see, if monoxide is there, we are just getting hydroxide. But if we have peroxide here, then we are getting hydroxide. But along with this, remember, there is formation of hydrogen peroxide. And if superoxide will take, there will be formation of hydroxide, hydrogen peroxide, and along with this formation of oxygen also. So this is a difference in the reaction of oxides of alkali metals with water, monoxide, peroxide and superoxide. Byproducts here we have to remember these will be different here. So alkali metal hydroxides, these are strongest bases. They are strongest bases. So that is why they will dissolve freely in water with evolution of large amount of heat. So this is about the first compounds, oxides and hydroxides of alkali metals. Next one now are halides. In case of halides, alkali metals, they are forming halides with the formula Mx. Like NaCl we can have. X can be fluoro, chloro, bromo or iodo. Any halogen can be there. Next is how they are prepared. Their preparation is by taking oxides of alkali metals or from hydroxides, and even from carbonates we can prepare them by adding hydrogen halide, HCl, HBr, these we can add. And what we get here is, in this case, Mx like NaCl. Along with this is water. Even in case of hydroxide also we get the Mx and water. But when carbonates are there, Mx plus water. Along with this, there is formation of carbon dioxide also. So this is how halides they are formed. Now the trends of these halides in the melting point and boiling point. Melting and boiling points, when we take of these halides, fluorides they have more melting and boiling point than chlorides. Chlorides they have more than that of bromide, and bromides they have more than that of iodide. The reason here is, if we take the metal same here, only halogen is changing and this one has high melting point. Before this also I told you the reason. That means the bond here is strong, and bond is strong means this is ionic bond, and ionic compounds exist as lattice. That means there is high lattice enthalpy. It's difficult to break this bond. That is why the melting point of fluoride is more than that of chloride, chloride more than that of bromide, and bromide more than that of iodide. Iodide size is big, so it's easy to break this bond. Now, if we take lithium fluoride here, it is less soluble in water. And if we take cesium iodide, it's also less soluble in water. What's the reason for this thing? Two questions are here. One is lithium fluoride I'm taking. Small size, small size. So we know lattice energy is high. It's not breaking easily, so it will not dissolve in the water quickly. So it's less soluble in water. This is a reason for this thing. But now if we take cesium iodide, in this case the size of both is big, but still it is less soluble in water. In this case, that means the bond is breaking easily. Lattice energy is not high, it is low because size is big, bond will break easily. But still it is less soluble in water. So now what is the reason? It's not on the basis of lattice energy now. This is on the basis of hydration energy. So in this chapter, we have to see according to the question whether we have to answer using lattice energy or hydration energy. See, size of cation is very big here. If size of cation is very big, in this case, hydration energy will be less. Cation size is big, hydration energy is less, so it will not dissolve in water. While here lattice energy is high, that is why it is not soluble in water so much. So both of these are less soluble in water, but reasons are different. Sometimes reason will be based on lattice energy, and sometimes you have to take it according to hydration energy. So these type of questions in this chapter are very important. Now next compound after halides is salts of oxoacids. First of all, what is the meaning of oxoacid? These are those acids in which acidic proton means that proton which is responsible for acidic nature of this acid is present as hydroxyl group, not as H alone, it is present as OH. For example, H2CO3 is oxoacid, H2SO4 is an oxoacid. Like if I draw structure of sulfuric acid, it's like this. Both these hydrogens are present as OH, not as H. It's not H only, it's OH. And only these hydrogen are replaceable which are present as OH. So these kind of acids in which OH is there and that H of OH is responsible for its acidic nature, those acids are known as oxoacids. Now alkali metals, they form salts with these acids. That means they form carbonates, they form sulfate, and these are soluble in water and thermally stable also. Now one question, lithium carbonate. I said they are thermally stable, but lithium carbonate is not so stable to heat. It is not stable to heat. Reason here is lithium size is small. If size is small, it will polarize. Cation size is small, so it will polarize the anion, that is carbonate, which is big in size. And for polarization, cation size should be small and anion size should be big. And because of this, the bond between the two will not be stable. So lithium carbonate will decompose to form stable lithium oxide and carbon dioxide when we will heat it. So on heating, it will break up because polarization will take place easily and it will break up to form stable lithium oxide and carbon dioxide. So this is about the general characteristics of the compounds of the alkali metals. After this, now in group 1, we are left with two topics, that is similarities between lithium and magnesium, that is diagonal relationship. Reason we have done similarities in the properties is because of their similar sizes. So because of similar sizes, which properties they will match? Lithium and magnesium, they both are hard and they react slowly with water. Both of them, they react slowly with water. We have done lithium reacts with nitrogen. Similarly, magnesium also reacts with nitrogen and they form lithium nitride and magnesium nitride. So both they react with nitrogen. And just now we have done this question, lithium carbonate it will decompose on heating. Similarly, magnesium carbonate also decomposes on heating to form lithium oxide and carbon dioxide. This forms magnesium oxide and carbon dioxide. Then we have done that lithium salts are hydrated. Even magnesium salts are hydrated. Hydrated means there is water of crystallization. So we can say they are deliquescent in nature. Lithium salt exists as like LiCl with 2 water molecules. And if we take magnesium chloride, there are 6 water molecules. So both are hydrated they are in hydrated form, that is they are deliquescent in nature. So this is about the similarities between lithium and magnesium. Now next one here is the last part of this alkali metal is anomalous properties of lithium. Actually, the properties which are in diagonal relationship of lithium with magnesium, these properties only they match, they do not match with its own group elements. What's the reason for the first element of a group to show anomalous properties? Because the first element has a small size. If size is small, its electronegativity is high. So it has high electronegativity. Then just now we have done small size cation means polarization will be more. If polarizing power is more, it will show covalent character. Reason for anomalous properties of first element of any group is this. Now which properties of lithium they do not match with other alkali metals? Difference between lithium and other alkali metals. See what we have written here in the similarities. It's hard. It's hard, while other alkali metals they are soft. Melting points and boiling points are high here because it's hard. Then this we have done that this has its compounds are in hydrated form. Then it reacts with nitrogen. Lithium is the only alkali metal that reacts with nitrogen to form lithium nitride. Then that lithium chloride, this shows somewhat covalent character. Then lithium carbonate, this one decomposes on heating. Other alkali metal carbonates are stable on heating, but lithium carbonate will decompose on heating, and this is obtained in a solid form. Next, one more property here is lithium nitrate. When we heat, it will decompose to form lithium oxide, nitrogen dioxide, and oxygen will be formed here in this case. But if we take any other alkali metal nitrate, like sodium nitrate, if we'll take, it will change to NaNO2 plus oxygen. So there is not oxide and nitrogen dioxide. In this we have nitrite. So this is the difference between lithium and other alkali metals.